So now we're actually going to use the inverse to solve an equation. So I want to find the inverse of this matrix first. So I'm going to use my little trick because it's a 2 by 2. So I'm going to do 1 over 8 minus 14, and then times, switch the places of those, switch the signs of those. And so it's going to be negative 1 over 6, so because 8 minus 4 is negative 6. And then I'm not going to distribute it in because it'll just make the fractions nastier, and I'd rather not. So this is our inverse, and what we're going to do is we're going to multiply this inverse by both sides of the equation. And you can check it. If you multiplied this by this, it will give you the identity matrix, the 1, 0, 0, 1, and then if you multiply the identity times x, it'll just be x. And so x is going to equal this inverse, 274, times this guy here. And so now we can just work this out, and this will be our answer. A couple ways you can do this. You have to be a little bit careful here. Matrix multiplication is not commutative, but scalar multiplication is. So I'm going to go ahead and give this negative 1, 6 to this guy and say that this is positive 1 and a negative 2, and that'll make this a little bit nicer. So if I just multiply these two together, it'll be 2 minus 4, and then 7 minus 8, so it's negative 2 and a negative 1. And so that should be the matrix that we're looking for. And there you go. If you wanted to check it, let's check it. So if I took the original 4, negative 7, negative 2, 2, multiplied it by this negative 2, negative 1, I get negative 8 plus 4, negative 8, oh, that's a negative 1, thank goodness. Negative 8 plus 2, and that does give me the negative 6 that they have there. And then I do 14 minus 2, and that does give me the 12. So amazing, we did it. And we will do it again.